Dear friends, I am Dr. Tamrakar. I am teaching you fluid machinery. We have started in our earlier class impact of jet to the flat vertical plate. Now, today we will discuss the impact of jet on inclined plate. Now we will study the force exerted by a jet, force exerted by a jet on a stationary inclined plate, on a stationary inclined plate. Here the jet coming from the pipe, and this is the nozzle, this is jet, and the plate is inclined here, fixed here. This is inclined plate fixed here, and the jet coming from here. Here with a velocity v meter per second, and after striking the plate, this jet flows through this direction and this direction. The water is flowing in these two directions. Here the angle, here this angle is theta, and this jet fx in fx direction. So here the component that is perpendicular to the plate, this is perpendicular to the plate, is making angle 90 minus theta. This is Fn component, and this is V sine theta. This is V sine theta. This is Fx, and this is 90 minus theta. 90 minus theta. Now, V is the velocity of jet in the direction of x. Theta here angle between the jet and the plate, and A is area of cross section of the jet. Now let us find the force exerted by the jet on the plate in the direction normal to the plate. Let this force is represented by Fn. So Fn equal to mass of jet striking per second into initial velocity of jet before striking initial velocity of jet before striking minus the final velocity of jet after striking the plate. Here Fn is the mass of jet striking per second into initial velocity of jet before striking in the direction of n minus final velocity of jet after striking in the direction of x, in the direction of n. So this comes rho a v into v sin theta minus 0. After striking in direction of n, there is no jet flow, but all jet will flow in direction of v sin theta as we have shown in the diagram. So this value coming after this is rho a v square sin theta. Okay. This force can be resolved into two components, one in direction of jet and other perpendicular to the direction of flow. Then we have Fx, equal to component of Fn in direction of flow, that is Fn cos 90 minus theta, So this value comes rho, that is rho a v square sin theta is the value of Fn, and cos theta 90 minus theta, so this cos 90 minus theta is also sin theta. So this is also sine theta. So this component, value of the component is coming to rho a v square, rho a v square sine square theta in the direction of x. And similarly, finding out the component in direction of y, fy, in the direction of y, that is fy equal to component of fn perpendicular to component of fn, component of fn in the direction perpendicular to flow, perpendicular to flow. So the value comes fn sine 90 minus theta, fn sine 90 minus theta. Now putting the value of fn, we will get rho a v square sine theta into that comes that sine 90 minus theta, this changes to cos theta. This is cos theta. Okay, so here the value comes rho a v square sine theta cos theta. Okay, now we'll take one numerical. A jet of water of diameter 75 mm, here diameter is given 75 mm, 75 mm. After reading the question, you should mark the data given and convert into meter, 0.075 meter, that divided by 1000, that will give the meter. And now moving with a velocity of 25 meter per second, here velocity is given, velocity is equal to 25 meter per second, this is v given in the question. And strike a fixed plate in such a way that the angle between the jet and the plate is 60 degree. Here the angle is given, theta is equal to 60 degree. These are the data given in the question. This is the angle between the jet and the plate. Now find the force exerted by the jet on the plate. First, in the direction normal to the plate, in direction normal to the plate, and second, in direction of the jet, So here we have to first calculate area A, that is equal to pi by 4 d square, putting the values pi by 4 into d, 0.075 meter square. This value comes 0.04417 meter square. Now we have to find the Fn Fn equal to rho a v square sine theta. Now putting the values, as we know the value of rho is 1000 for the water, and A we have calculated, just that value comes 0.004417, and value of V is given 25 meter per second, and the angle is sine 60. Now calculating this, we'll get 2390.7 Newton. This is the force exerted in the normal direction. Next, for the force in the direction of jet, Fx, force in the direction of jet, Fx equal to rho a v square sine square theta. Putting the values, value of rho is 1000, value of A is 0.004417 into V 25 meter per second into sine 60 square, sine square 60. So here we'll get the value of Fx, that comes 2070.4 Newton Fx. Similarly, we can take more examples, and we have to practice different questions because these questions are important and have asked in the examination. You can take the questions of university question paper from CSVTU online or online csvtu.com. You can find out the question papers of previous years. Okay, thank you. Next, we can do more and more numerical. Here, the next question is: a jet of water of diameter 50 mm strike a fixed plate. Here diameter is given 50 mm, that strike the fixed plate. 50 mm, we have to convert the 50 mm into meter, that is 0.005 meter. Then we have to read now: a fixed plate in such a way that the angle between the plate and the jet is 30 degree. Here the angle between the plate and the jet is given theta equal to 30 degree angle has been given. Now the force exerted in the direction of jet is 1471.5 Newton. Here the force exerted in direction of jet, that is Fx, is given 1471.5 Newton. Now we have to determine the rate of flow of water. In this question, we have to determine the rate of flow of water. So for this, first we have to find out the area equal to area A, that equal to pi by 4 d square, pi by 4 d square. Putting the values, we'll get, this is 0.05. this is 0.05. Okay, so here we will get pi by 4 into zero point 0.5 square of 0.5 square of 0.5. So we'll get an area of this comes 0.001963 0.001963 meter square. And as we know, the force in the direction of jet Fx, we are knowing 1471.5. Now the formula of Fx is equal to rho a v square sine square theta. So putting the value here 1471.5, this is rho is 1000 for water and the area is 0.001963 into velocity. Here the velocity we have to find out the velocity, and sine square theta has been given here. So this is v square into sine square 30. Here the angle is given 30. So here we have to find out the value of v. This value comes 354.77. This value comes 54.77 meter per second. And here in this question we have to find the rate of flow of water. So for finding the rate of flow of water, we have to find that is Q equal to area into velocity. Area into velocity. So here putting the values of area and velocity 0.001963 into velocity is 54.77. So here quantity comes equal to, here this quantity point 0.107575 meter cube per second. This is meter cube per second. This can be converted into liter, 107.5 liter per second. By multiplying 1000 here we will get. So in this type of questions, some questions can be we have to do in different way, that here we have to calculate velocity, and then by using this velocity we have to find out the quantity rate of flow. Okay, so this comes 107.5 liter per second. You have to solve the similar type of questions for your practice. Thank you.